Here we see a person who's pushing on a large crate across a rough surface. Here a rough surface implies that there'll be friction involved. We want to identify all the interactions, show them on an interaction diagram, and draw free body diagrams for the person and the crate. When we want to identify the interactions, we can treat this situation similar to what we did in a force identification diagram. We can draw a line around each of the objects that we're interested in and look at what they interact with, and that way identify forces that may exist. When we look at the person, we see that they are touching the crate and the crate is touching them, and so we have a chance for a force. We'll actually have forces in both directions. This person is also touching the floor. As before, there should be a normal force and a force of friction. In this case, the force of friction is to the right, because if he is pushing against the floor, if there were no friction, his feet should be moving to the left, so their force of friction must be pushing back to the right to keep his feet stationary. And then, as always, there will be gravity acting on the person. Similarly, for the crate, we have this pushing acting between the two. The crate should be moving to the right if the person is pushing on it. So being in contact with the floor, there should be a force of friction on the crate to the left, a normal force holding the crate up, and a gravity pulling the crate down. So all of that's similar to what we've seen for the force identification diagrams. Now we want to draw a interaction diagram. And in an interaction diagram, we want to draw circles representing the person, and representing the crate. And we know that there's a force acting between those two. That's the force of the push that the person is applying to the crate. There's also a surface that they're both standing on. That surface has a friction between both the person and the crate. There's also a normal force acting between the person and the crate. Finally, both the person and the crate are subject to gravity, and so there's a force of gravity between the person and the earth, and between the crate and the earth. And thus, this is our interaction diagram. We put a box around the system in question. The system is the things that are moving here. In this case, it's the person and the crate. Outside of the system are the surface and the earth. Both of those count as the environment. They affect our system, but they are not directly part of the system. So we see here we have two objects, so we should have two free body diagrams. For the person, we'll have gravity downwards, and we'll have a normal force that's upwards. That's fairly typical from what we've seen, where the normal force balances out the force of gravity. We also know that there is a pushing force. If the person is pushing the crate to the right, then the crate must be pushing the person to the left, and thus we have a force of the crate acting on the person. We also said if the person is pushing the crate to the right, the person themselves should be sliding to the left. The reason that they're not is that there's got to be a force of friction holding them in place so that they'll have they'll be able to do the pushing on the crate. Going the other way, we have the crate we can consider as well. Like before, we have gravity acting downwards. This is the mass of the crate times gravity. And a normal force upwards, balancing that gravity out. The crate is being pushed by the person. It's being pushed to the right. So there is a force of the person acting on the crate. If the crate should be trying to slide to the right, it will be resisted by a force of friction acting to the left. The last step, we know that the gravity is acting with the earth for both in both cases. The normal force is acting directly with the surface in both cases. The force of friction is being balanced with the surface as well. But the force of the crate pushing on the person, the force of the person pushing on the crate, that is an internal force to the system. And thus, those values should have equal magnitude. And so if you wanted to set up a set of equations to solve, you would know that these two forces have the same amount.